talk about quantum computing, it's a completely different game.
Quantum computing will enable us to solve problems that currently take longer than the lifetime of the universe in seconds, hours, or days.
We completely reconceive the space in which we do computation.
Quantum computing is like going from crawling to going to a different planet. It's different.
It's only natural that we would want to use the world's most powerful device to combat the world's most challenging problems.
We could attack global warming.
Security,
What are the boundaries of machine learning?
fighting diseases. The possibilities of quantum computers are endless. Microsoft has the best and the brightest working on this problem.
It's really happening. Progress is very fast, and we're building a quantum computer.
What the world wants to know is what happens when we turn the machine on.
What problems will be solvable with a computer that computes in a billion parallel universes at the same time?
So good morning, my name is Salman, and today I'm going to be giving you guys a brief overview of what quantum computing is. So all of us may not feel it, but we are currently living in a very exciting time where we are part of the fourth industrial revolution. Technology is advancing at a rapid rate, and we can see it has revolutionized the world that we live in, enhancing the way we live, work, and interact with one another. One could even say that technology has become a necessity that many companies like BGL Group, Microsoft, or IBM rely on, where we use IT systems every day to input, process, and output data with speed, power, and accuracy. Satya Nadella, the current CEO of Microsoft, says in his latest book, Hit Refresh, that these three fields of mixed reality, artificial intelligence, and quantum computing are going to be the three major players to shape the world of the future and revolutionize technology. And today, of course, I'm focusing on quantum computing, a new idea which brings together the fields and concepts of mathematical, physics, and computer science backgrounds to give you something new entirely. But before we get to that, it's important to understand how our traditional everyday computers work. So classical computers work on the principles of binary movement. Transistors within chips act as switches to either allow or restrict the flow of current. This in turn makes transistors logic gates, where information can be encoded into bits as ones and zeros. But what does that actually mean? So if we have a look at a problem over here, which is a puzzle, the goal is to get to the bulb in the middle. So a classical computer will try and solve this sequentially, going through every possible path one by one, step by step, until finally it reaches the solution at the end. So though this works, with an ever number growing of problems in the world that are more complicated, much more bigger, classical computers inevitably reach a plateau into how fast and efficient they can compute stuff. And this is where quantum computing comes in. So to explain quantum computing, I'm going to give you a little bit of an overview of quantum mechanics. So anyone heard of Schrödinger's cat in this room? Hands up. So Schrödinger's cat is a theory to explain quantum physics. The theory states simply, if I seal a cat inside a box with a vial of poison, which I wouldn't do ever because it's obviously really inhumane and cruel, but hypothetically, if I seal a cat inside a box with a vial of poison, and that vial of poison is on a counter set at random, after 24 hours, what can we say about the state of the cat? Is the cat dead or alive? Hands up if you think the cat's dead. Hands up if you think the cat's alive. Yeah, you're both correct. Because at any given time, no one can be sure and confidently say if that vial of poison is broken or is intact. So this gives the cat two states, dead and alive at the same time. And in quantum physics, this is known as a superposition. And this is what quantum computing is all about. We replace our traditional bits of ones and zeros with a quantum bit, or otherwise known as a qubit, which allows not just two states, but infinite states at the same time. But what does that mean? So if we go back to our original problem and we replace our classical chip with a quantum computing chip now, any ideas what do you think would happen?
It's going to do everything at once.
Exactly. So if I play it, the quantum chip can use the power of a superposition to navigate every single path at the exact same time, thus reaching the center a lot more quicker and efficiently. But just how powerful is quantum computing? If we look at the global standard for encryption, RSA 2048-bit cryptography, it would take a standard computer 1 billion years to find the 2 prime numbers needed to solve that encryption. Any guesses how long a quantum computer would take?
Seconds.
Seconds? Any other? Minutes? 100 seconds to decrypt that. Isn't that remarkable? But I know what some of you are thinking, oh, our privacy is screwed, what's going to happen with security? But no worries. With new levels of decryption, Microsoft is also working on something called post-quantum crypto, which is a new measure to safeguard against these new technologies. So quantum computing also allows for exponential scaling, where we can see 30 qubits of quantum bits would be the equivalent of 16 gigabytes of RAM. 40 qubits would be 16 terabytes, and 50 qubits would be 16 petabytes. Microsoft aims to scale at 1,000 qubits. Just imagine the power and the possibilities. So you might be wondering, we can already add servers, add more chips, so why do we really need quantum computing? So as I mentioned, there's a number of growing problems in the world that are more and more complicated, and classical computers would take a much longer time, just like that decryption. So problems such as climate change. Quantum computing will help us to find new ways to reduce our carbon footprint and tackle global warming. It can also help end world hunger by finding up new methods to sustain our crops. It will also help in the medical industry, where antibiotic resistance. So over millions and millions of years, viruses have evolved and adapted to become immune to the vaccines that the doctors give us today. What a quantum computer can do, it can predict how the virus will evolve in the years to come and let doctors make vaccines for the evolved viruses, so help fight diseases in the future. So a lot of you might be thinking, well, this is all theoretical, how will this happen? This is all science fiction. Well, Microsoft have an entire division of quantum computing, where they call it the Quantum Dream Team, of the best specialists around the world in every country that work every day together and use their skills and intellect to turn this dream into a reality. So where does it currently stand? So Microsoft is practicing to use electron particles in the computers to act as qubits. The goal is not to have as many quantum bits inside the chip, but to rather create the most optimized and efficient qubits, and Microsoft called this the topological qubit. The idea is, if you build a house made out of cards, it's not robust, it can easily topple over. If you make a house made out of Lego bricks, you have a solid foundation, and once you get that correct, it's a lot easier to scale upon. This will result in a more accurate and error-free computation. So recently, they had something known as the Majorana breakthrough. Now what that means is, in Microsoft Lab, they were able to create an atmosphere colder and darker than space. So at a temperature at absolute 0 Kelvin, which equates to minus 273 degrees below zero, Microsoft could create a state where atoms are almost motionless. And at this state, they saw the event occur of a superposition, where a particle had an antiparticle. So like I mentioned, 2 states at the same time. So because they saw this event occur, they now have evidence that they can now build upon to create a quantum computer. So where is it currently? Todd Holmdahl, he's the VP of the quantum team, he stated in his recent interview that they hope to have the first topological qubit ready by the end of 2018, which is a lot sooner than we might think. So there you have it, a brief overview of quantum computing, a technology that will bring an end to one era and the dawn of a new. Thank you for listening.